And let's get the notes. You should have them from the cart today. On the cart, you have these notes. You also have the assignment from yesterday's notes. So you have plenty to work on once we're done with this. You also have the test review for the 6 weeks test. That's on Thursday. And if you don't have that or need an extra copy, there are a few left in the in the first drawer over there where all the papers are. You can get one there. Let's just go ahead and get right into this. I'm going to try to be as simple as possible, but just follow along. And if you need to replay a part of the video, then we can replay it. But this should be self-explanatory. And there's really two big equations here. We're talking about direct and inverse variation. And direct variation is when y varies directly as x does. Inverse is when y varies inversely. When we say varies, that means we're changing. So when we talk about direct variation, the equation, and these are biggies, because this is what you're going to need to solve the problem. If the question says it's directly inverse, or it varies directly, there's your equation. Y equals k to the x. Okay. As a graph, what does that look like? And how can you tell from a graph? And we've talked about this earlier this year, but how can we tell? It goes to the origin. So again, it goes to the origin, and it has a positive slope. Goes to the origin, and it has a positive slope. If it does those two things, origin, positive slope, then that is a direct variation. But again, big things right here, the equation, and it goes to the origin, has a positive slope. Inverse variation. Okay, y varies inversely, so basically opposite as x. So the equation here, so the big one here, is y equals k, which is going to be the constant. K in both of these is the constant. Y equals k over x. And what does that look like? Well, it can look like this. You can get a problem here, or it could look like this right here. Notice as x gets bigger, the y is getting smaller. That's why it's inverse. On the direct, as x gets bigger, y gets bigger. Inverse, x gets bigger, y gets smaller. Let's do a couple examples here for this. Number one, I can try to zoom in a little bit. Hopefully you can see this. Do a little focus in here. Alright, that should be good enough. Number one says Tim's Toy Company makes toy race cars. Each worker can make 3 toy cars in one day. So our axis here, the x-axis, that's the number, the number of workers. The number of workers. The y-axis, that's how many cars they can produce. And we're talking about one day. Number of cars per day. Number of workers, okay? So if we have one worker, well, the one worker can make how many cars per day did it tell us? 3. How did we find that? We said 1 times 3. Okay, if there were 2 workers, well, 2 times 3, that would give us 6. 3 times 3, that'd give us 9. 4 times 3, that'd give us 12, and you can see the pattern going again. Plus 3, plus 3, plus 3, plus 3, and plus 3. So let's graph these points. If there were 0 workers, there would be 0 cars. 1 worker, there's 3 cars. 2 workers, there's 6 cars. 3 workers, 9. It's going up 3 and over 1, up 3 and over 1, up 3 and over 1. This is linear. Okay, if we graph that, it goes through the origin, has a positive slope. All right. Now the question says, is the function that models the situation a direct variation or an inverse variation? Well, we can tell, okay, how do we know it's direct? obvious. I mean, how can we tell if it's direct? If we refer back to what we just looked at the top, does it go through the origin? Yes. Is it positive? Yes. Is it represented by the equation y equals kx? Well, it's going up by 3 times. That would be y equals 3x. So, yes. So there's an example of a direct variation. If you flip it over, inverse. Number 2. Okay, here we go. Got an attic. Next, jewelry boxes. Takes one worker 1 hour to make the jewelry box. The neighborhood department store has just ordered 30 boxes. So there's 30 boxes. All right, x-axis. Again, that's going to be the number of workers. The y-axis, this is going to represent number of hours to complete order. How do I know that? Because it's right there in the table. Number of hours. So I'm just going to put hours. Okay, there's 30 boxes. If there's 2 workers, well, it says that it takes 1 worker 1 hour. So if there's 2 workers, and there's 30 boxes, how long is it going to take? Well, take your 30 boxes. How many workers are there? There's 2, so we divide by 2. That equals 15. 30 boxes divided by, if there's 3 workers, divided by 3 equals 10. You can see the pattern. 30 divided by 4, 7.5. 30 divided by 5, 6. 30 divided by 10, 3. 30 divided by 15, 2. And what we're doing there, the y value, so 15, 10, 7.5, 6, 3, 2. The y value, how did we get that? We did 30 divided by the x value, which is the number of workers, which is x. If you plot these points, 215 is up here. 310 be right there. 4 and 7.5, so 7.5 would be between 7 and 8. And then you got 5, 6, so 5, 6 right there. And the next one jumps to 10, 3, over here 10, 3. And then the last one we have is 15, 2. You got your points, okay? If you graph these, my pen's not very good. If you graph these, you can see the graph. Notice as x gets bigger, so as x gets bigger, going to the left, the y value up here, the y value gets smaller. X gets bigger, y gets smaller. That is going to be inverse. Inverse variation. Is the function that models the situation a direct or inverse variation? Explain. Well, we found y equals 30x. And we know inverse is y equals k divided by x. So, yes, that is an inverse variation. We can also tell by the graph. All right. Now here's some 3, 4, 5, 6, some more examples. Just follow the steps here. It's going to be similar to the assignment, which I don't have copies of. I'm going to try to get to you tomorrow. If y varies directly as x and y equals 80 when x equals 32, find x. Okay, there's a lot. If you just read it all, there's a lot of stuff going on. Let's break it down piece by piece. If y varies directly, so we're talking about direct variation. So right above that, right there I wrote y. I know right now I'm dealing with y equals kx. That's the equation I'm looking for. Y equals kx. Okay. The next part that says y equals 80 when x is 32. So using our equation, and I have this all worked out right here. Using our equation, y equals k times x. We said y equals 80 when x was 32, but we don't know the k. Well, let's find the k. How do we do that? Well, easy. Divide by 32. Divide this side by 32. When I do that, wrote over here, k equals 2.5. Alright, so now the last part of this says find x when y is 100. So I just wrote it out again. Y is 100 equals, we just found that k is 2.5, so that's where we got 2.5. and then it says find x, that's what we're looking for, x. So this time I'm going to divide by 2.5, divide by 2.5, 100 divided by 2.5, calculator, go to work, 40, x equals 40. So the answer on this one is 40. Started with knowing direct variation and using that equation. Plugged in y, plugged in x, we found k, and then we plugged in our new y and found in our new k, in the k, and we found the new x. Okay, let's look at number 4. If y varies inversely, okay, so again, right now, inversely, that's y equals k divided by x. Again, y equals 40 when x is 16. So let's fill this in. Y is 40, so y equals k divided by x, and it says x is when x was 16. Okay, let's solve for k. So how do I do that? Well, multiply by 16. Because when I do that, 16 cancels with 16. I have k equals 16 times 40. Calculator, go to work. 640. K equals 640. Now, let's find this new part. It says find y when x is 10. So again, my equation. Don't know what y is. We just found that k is 640, so that's what goes on top. Divided by, it says our x is 10. 640 divided by 10, y equals 64. Alrighty. Alright, here we go, kicking it up a notch. The circumference C of a circle varies directly as the diameter D. So we're talking about direct variation. So that's why the first thing I wrote down is y equals kx. But now it doesn't have, y and x this time. It has C and D. So look back up here at how this is worded. Y varies directly as x. C varies directly as D. So in this case, C is your y, D is your x. So I wrote C equals k times D. And at this point now, it's exactly the same as the last two problems we've done. Let's see what it tells us. If the circumference is 44 when the diameter is 14. So again, C is the circumference, so that's 44 equals k times, and it says the diameter is 14, so D is 14. Okay, solve this. So we divide by 14. Divide by 14. Calculator, go to work. 44 divided by 14 gives me 3.14. Hey, look at that. Pi. Circumference equals pi times diameter. So, a little heads up. So K is 3.14. Let's continue now. It says, find the circumference when the diameter is 21. So, we don't know the circumference, but we just found K was 3.14. And we know that the diameter, our D, is 21. Calculator, go to work. 3.14 times 21. C equals 65.94, and I think we're talking about centimeters. There you go. And the last problem on here for this set of notes, it's the same type deal. We got the force needed to move a rock varies inversely. So first thing I'm going to write down is y equals k divided by x as the length. So again, y varies as x. So F is y, L is x. So I'm going to put an F right here equals k divided by not x but L. Now let's read and see what it tells us. The length is 80. The force, or F, is 1.5. So I'm going to rewrite this equation. It says, okay, the force is 1.5 equals, we don't know k yet, divided by L. The length is 80, so I know that's going to be an 80. Let's find k, so I multiply both sides by 80. When I do that, 80s cancel. So that's what we're trying to do, get k by itself. So now I got k equals 80 times 1.5. That's where I got 120. Now we're going to find the force needed when the length of the crowbar is 120. So find the force. So we're looking for F. So F equals, we said K was 120, and it just so happens on this problem that the length is 120. So 120 divided by 120, we know that that's going to be 1. So F equals 1. Okay, those are the notes, and hope y'all are doing well. We'll see y'all tomorrow. Don't forget to get that review completed. The video is on Blackboard, and you have the rest of today to be working on the assignment for yesterday's notes or the review. Okay. We'll talk to y'all later, guys. Hope you're doing good.